Saxon Algebra 2, Lesson 75. Factorable denominators. Here comes a nice straight algebra lesson in which we will find out how to deal with some tricky situations. Let's jump in. We have two big, crazy looking fractions and we are asked to add them. Technically we're subtracting, but adding and subtracting have sort of blurred to the same thing at this point in our lives. Okay, so we look at this and we go, okay, we're adding / subtracting fractions. That means the denominators have to match, and we look at this and go, oh, Lord have mercy, that's not even close to matching. That's a nightmare. But what our brains see next is that this is factorable. We could break that down into binomials, and maybe one of them would look like that. So let's do that. Let's break this down. We know how to factor a trinomial. We know it's an x. We find the two numbers that multiply to this and add to that. This is a -1. We can write that in. So we know this is going to be -3 and +2, right? They multiply to -6, they add to -1. Okay, good. Now I'm just going to squiggle that out so my eye doesn't look at that anymore. Now, we see what we wish is that one or the other of these was over here. And we see, oh, this is close, but it's not quite. But then we remember we have this trick. If we multiply top and bottom by -1, we can change that so it'll look the way we want. So this becomes, let me just rewrite everything. X plus 3, my bad, over x minus 3, x plus 2, minus, now this becomes a -3 up here, and this changes, this becomes positive, this becomes a negative. I'm gonna write them in the opposite order. It's x minus 3, hallelujah. Okay, now I notice something else. These two can go together to make a plus, can't they? So I'm going to change that on the next time around. I also see that I can have matching denominators fairly easily. If this is my least common denominator, I can just multiply by this second quantity, right? X plus 2, because I have to do top and bottom. Wouldn't want to miss that. Right? So I can multiply, pretend there's a gap in the line, and I'm multiplying. That, now they'll match, right? So let's do this. Let's push them together into one big fraction. We'll have x plus 3 plus 3 times the quantity x plus 2. This second numerator has to be multiplied by this. So there's where I'm doing that. And then this will all be over x minus 3 quantity, x plus 2 quantity. This multiplies out. It'll become 3x plus 6. I'm going to scribble that out. Now I've got this. Now I combine the x's, and then I'll combine the plain numbers, and I'll get 4x plus 9, right? The x's, the plain numbers, all over. Denominator is the same. That is our answer. That was a pretty robust calculation. Remember that the tricky part was we had to, first of all, remember to factor this. That doesn't always jump into a student's head. The other thing is that we had to remember that we can make this one look like this one if we multiply top and bottom by -1. And then we have to be careful with these two minuses. Let's try another. Are there 3 in this one? Yeah, there's 3. It's my favorite kind of lesson. Boom, boom, boom. Done. Okay, example 75.2. Add. It's the same kind of scenario. As we write out the problem, and sometimes it does help to write it out. If you just look at it in the book, it doesn't always crack your brain open. Here's a trinomial we can factor. And then we look at what's in the other denominator and go, ew. Let's hope we're going to be multiplying that by -1 because that's just nasty. Okay, let's factor this. Two numbers that multiply to 1 and add to 2. Well, that's pretty easy. right? Squiggle this out so I don't look at it. Now I can see, all right, if I can make both of those positive, yes, I'll have one of these. Then I'll have to multiply by the other. So I'm going to multiply top and bottom by -1. I'm going to be very careful with that. So this will give me x plus 7. Gracie's having some nice little puppy dreams. This dog knows more about math than all the other dogs wish they knew. Okay, this and this are going to make a positive. 3 times 1 is 3. So I'm going to write plus 3 over, and now this minus is fixing this to make it x plus 1. They both go positive, and I'm just going to rearrange their order. Now I see, okay, this looks really good. I have one of them. I need the other one. And I can smush these all into a single denominator. I just have to remember to distribute. This 3 is distributed against that, okay? These guys are minding their own business. Their denominator's fine. It's just the 3 that has to be multiplied. So I'm gonna get x plus 7 plus 3 times the quantity x plus 1. I'm just gonna do the numerator first. The denominator's fine. I'm gonna distribute x plus 7 plus 3x plus 3, and then I'll put together the x's and the plain numbers. 4x plus 10 over, our denominator has been fine for a while. This is the form I like to see it in. It looks beautiful. Distributing in the top was important because we created some like terms. Just multiplying this out in the bottom, not necessary. I prefer to see it in the binomials. That feels simpler to my brain. It's not right or wrong, but this is kind of mathematically desirable. Okay, last one. Example 75.3. And I will say that the answer in the book for this example is wrong. So if you look at this example in the book, 75.3, it's wrong in the book. I'm going to show you the right way to do it. Sorry, John. Get your editors busy on that. Okay, it's the same kind of problem. Add x minus 3. I don't need to say it out loud, sorry. I've been going really fast. And I'm sorry if you feel rushed. I get so excited, I'm not gonna lie. Okay. So again, we notice that this can be factored. And let's see, it'll be x minus 5, x plus 3. I hope by now you're feeling pretty comfortable with this calculation. They multiply there and they add there. We can squiggle this out, we don't need it. And this time we see, hey, look, it's already just the way we want. I'm gonna put parentheses around because I'm gonna be multiplying by another binomial. This looks great. We don't have to do the multiply by -1 trick. We just have to multiply by x plus 3. And what makes it tricky is look what we've got up top. Now we have to multiply things like that. Before we just had a plain number here. All right, fine. Okay, x minus 3. Now let's multiply this and see what we get. It's x plus 2, x plus 3. So we're gonna do the dance, right? The kids are in the dance studio. It's Saturday morning. These are the boys, these are the girls. We dance. X squared plus 2x. This girl is done, this one's turn. Plus 3x plus 6. We add it together and we get x squared plus 5x plus 6. And that goes up here, right? This is part of our numerator. So I'm gonna keep going. Plus x squared plus 5x plus 6. The reason I multiplied this out, and if you're the kind of person who likes your homework to look really perfect and neat, I'm with you. Make it into a little, make your side calculations into a box so that they're kind of separate from the flow of the problem, but they're right there. This is an important part of the solution. Don't feel like it's ugly and stupid and you don't want it on your paper. You need these calculations. So put them in a box if you like. Sometimes that will help. The reason it was important that we multiplied that out is because we have created some like terms, right? Now we have two x terms and we have two plain number terms. So we would not have seen those if we had not multiplied out these two binomials that we got. These two. All right, let's combine. We have x squared, that's right there, plus 6x plus 3, right? Plus 6 minus 3 is plus 3. And all of this is over quantity x minus 5 times quantity x plus 3. That is the right answer. That is not what John has in the book, so don't listen to him. And this is a lovely form. Okay, we multiplied out in the top so we could combine like terms. We leave this in the binomials. All right, that is lesson 75, in which we learn how to play with our fractions a little bit in order to get them to match up denominator-wise. And using this -1 is one of our favorite tricks. All right, that's lesson 75. Thank you. Goodbye.